So if you look on OneNote, you'll notice the tab that I'm on right now says Handout Conversion Factors. For lack of better words, I couldn't really think of anything else to call it but a handout, because it's normally something I would print off and give to you, but paper's not a thing anymore. So the handout's here, and really, it's probably easier to have it here because you'll know where to look for it. You won't have to flip through a binder. You'll have it any time you're looking at OneNote. So last class, we talked about metric conversions, where we had to remember the metric prefixes. Today, we're talking about conversions where they're non-metric conversions, like inches to feet, and inches to centimeters, and days to hours, years to days. And so this handout has some useful conversion factors for you. It's even got temperature conversions and the formula for density, just in case you don't remember it. So at the very top, you'll notice it says you don't need to memorize these. You do not need to memorize these conversion factors. When you guys take your tests, you're going to be taking them on the computer. So can you access your OneNote? Yes, so you can access them there, and I'll remind you of that. So you don't need to memorize these. Some of them you probably already do have memorized, like inches to feet. You probably know that. But these are the conversion factors we're going to be using as we go through problems where it's not just a metric conversion. So I'm going to go down to the next tab. And so today, I'm recording now this video. So this video will go where it says Ms. Brink's lesson video. We're going to be talking about a method for converting units, and that method is called dimensional analysis. I'm not going to ask you what is the name of the method that we use to convert units. All dimensional analysis is a way to think through putting together conversion factors. And all we're doing when we do this is multiplying fractions, okay? So when we're working out these problems where we have to use conversion factors, if we look at this, what we call a t-table, because it kind of looks like a T, at the very top left, we start with what we're given. With its unit. And that's going to tell us where to start. And then we draw this little T shape, which is just a way to keep us organized. All we're doing is multiplying fractions. And then we're going to piece together conversion factors. Do we have to memorize those conversion factors? No, where are they? They're on that handout that you have in OneNote. We're going to piece together conversion factors so that our units go from what we're given to what we're trying to find. So I'm going to give you a minute to write this down. I know it may seem like a weird thing to write down, but if you'll just humor me and write it down in your notes. Okay, so let's talk about some conversion factors that we're familiar with. So, how many quarters are there in $1? 4. So I can say $1 equals 4 quarters. Is that true? And I can say 4 quarters equals $1. Is that true as well? It's true no matter which way I look at it. What about inches to feet? What's the conversion factor between inches and feet? 1 foot equals 12 inches. Can I say 12 inches equals 1 foot? So when we look at a conversion factor, they're equal to each other, right? One part equals the other. 12 inches equals 1 foot. And so I can write conversion factors as fractions because they're equivalent. So I can say 1 foot over 12 inches. That's true. Can I also say it the other way? Can I say 12 inches over 1 foot? Is that still true? Yes, that's still true. And so what I'm going to be doing when I talk about converting units, and you guys have done this before, so just bear with me, is take what I'm given, piece together conversion factors so that I cancel out the units that I'm starting with to end up with my desired units or what I want to end up with. But we are just multiplying fractions. So when we are multiplying a number by a fraction, like our starting value, are we going to multiply it by the numerator or divide it by the numerator? Anybody? Multiply? Then what are we going to do by the denominator? Divide? Right? Yes? Okay. So when we're looking at the units, whatever unit we have here will cancel out with what's in the denominator, or opposite, when we multiply fractions. Because what's on the top and what's on the bottom, they divide and can cancel out. And so that's the premise of how we're setting up using conversion factors. We're going to go over a bunch of examples so you'll be able to see the mechanics of it. So let's go through some examples. One note, and I would write this nice and big, is when we are using conversion factors, those conversion factors do not affect significant figures. Okay, so let's look at some examples together. So the first one, I'm going to make this a little smaller, or else my handwriting will look crazy. 565,900 seconds into days. So what are we given with units? 565,900 seconds. So that's what we're going to start with. That's our given, so we're going to start with it. If we didn't start with it, there's not really much else to go with. So we're trying to convert a whole bunch of seconds into how many days? So how many days are in 565,900 seconds? So we need to piece together conversion factors to go from seconds to days. And you may know some conversion factors that some of us just don't have stuck in our head. But we're going to start with seconds and go to the next unit of time that most of us are familiar with. So what is a conversion factor between seconds and something else that will help us get to days? Minutes. So what is that conversion factor? 60 seconds equals 1 minute. So that's the conversion factor. So how are we going to plug that into our t-table so that the units work out? We're going to put the 60 seconds on the bottom, and then the other part, what it's equal to, on the top. Why did we set it up that way? What did we want to happen to the seconds? We wanted them to what? Cancel out. And so they have to be opposite of each other. So if I stopped here and did 565,900 times 1 divided by 60, what unit would my answer be in? Minutes. Is that what I'm asked to find? No, I'm asked to find days. So I need to keep going. What's something I could use what's something related to minutes that I could use? Hours. So what's the conversion factor? 60 minutes equals 1 hour. So how are we going to plug that in? We're going to put 60 minutes on the bottom and 1 hour, what it's equal to on the top. Why did we set it up this way? So what will cancel out? Cancel out minutes. So if I stopped here and did 565,900 times 1 divided by 60 times 1 divided by 60, what unit would my answer be in? Hours. Is that what I'm asked to find? No. Now I need to go to days. So do I have a way to go from hours to days? What's that conversion factor? 24 hours equals 1 day. How am I going to plug that in? I'm going to put 24 hours on the bottom and 1 day on the top. So what unit cancels out at this point? Hours. And if we look at our t-table, what's the only unit that hasn't canceled out? Days. And is that what I'm trying to find? Yes. That's how I know I need to stop and go ahead and calculate. So let's talk about how we calculate this. We are multiplying fractions. There's different ways to do this and still get the same correct answer. So one way you can do it is you can take all the numbers in the numerator and multiply those together. Then separately, take all the numbers in the denominator and multiply those numbers together. And then take numerator divided by denominator, right? You can also, if you don't want to take those steps, you can also just start at the beginning, 565,900 times 1 divided by 60 times 1 divided by 60 times 1 divided by 24. Now, do you need to do the times 1 or divided by 1? No. You can if it helps you keep up with where you're at, but you don't have to because multiplying or dividing by 1 is going to give you the same thing. So you guys practice typing that into your calculator, and then let's talk about the answer. going to decide the number of significant figures? Same number as you're given, because conversion factors don't affect significant figures. So how many significant figures are there in the measured value in my problem? 4. There's 4 significant figures. Oops. Here. So how many significant figures should I have in my answer? 4. So what did you guys get rounded to 4 significant figures? I'm going to write something, and then we'll talk about it. This is the answer not rounded yet. So 6.5497. So 1, 2, 3, 4 significant figures. What is the 7 going to do to the 9? Round it up. So how are we going to write our answer? What is 9 going to round up to? It's going to round up to 10, which would round the 4 up to a 5. So how would we write that? We would need a 0. So 6.550. And what's the unit? Good. You guys want to try the next one? We're going to go over it together, but do you guys want to try it yourselves and see? Cool. So you guys work on 17 years into minutes. So I would do years to days. Now there are different ways to do this. So I would do years to days. So in 1 year, how many days are there? 365. If you want to get fancy, you could say 365.25, but it's not going to matter in the end. And then, so years cancel out. Then I would do in 1 day, there's 24 hours, and days cancels out. And then in 1 hour, there's 60 minutes. And hours cancel out. So in my given value, 17 years, how many significant figures are there? 2. So in my answer, how many significant figures should I have? 2. So what did you guys get? 8,900,000. Do I need to show a decimal point at the end? No. Do I need to erase those zeros? No. What kind of zeros are they? Placeholders. I need to have them to show the size of the number, but I can't accurately measure those digits, so I can't say anything other than 0. How are significant figures feeling any better now that you've practiced some? That's why we do significant figures at the very beginning, is because by virtue of this unit, you get to see measurements, so where significant figures come from, and you get to practice with significant figures when we do conversions. So we're given 22,647 inches, and we want to convert to miles. So where did you guys start? Feet to inches? So how did you plug that in? Good. Why did you set it up that way? So that what? Inches cancel out. I'm sorry. I'm normally not bad at hearing, but these maths are like, even in my small classes, I'm like, for some of my kids, it's like the perfect time for them to mumble things under their breath, and I know they're doing it, but then like in cases where kids are actually trying to answer questions, it's hard to hear. So we did that so inches cancel out. So if we stopped here, what unit would our answer be in? Feet. Very good. So now I want to go feet to miles. And this is one, you may have the conversion memorized, you might not. I still would double check it and look at that handout. And so do we have a conversion from feet to miles? 5,280 feet is equal to 1 mile. So how am I going to plug that in? Good. I'm going to put 1 mile on the top and 5,200, is it 80? Feet on the bottom. So at this step, what cancels out? Feet. And what's the only unit that hasn't canceled out? Miles. Is that what we're trying to find? So how many significant figures does my given measured value have? So how many should my answer have? 5. So when you guys tippity typed it in, you should do 22,647, and then either multiply the whole top, multiply the whole bottom and divide, or just go in order, multiply, divide, multiply, divide. So divided by 12, divided by 5,280, and what did you get? .35743, and then the unit, miles. Very good. Don't abbreviate miles with an M. Miles, you can abbreviate MIL, but M is just meters. So how'd you guys plug in the conversion factor? Why'd you decide to put 2.2 pounds on the bottom? Very good. And what does that equal to? 1 kilogram. So pounds cancel out, and we're left with kilograms, which is what we want. How many significant figures did our given value have? 3. So how many should our answer have? 3. So what'd you guys get? Okay, if we just write 75, is that 3 6 75.0. Very good. And that's a really easy zero to forget. And you can always go back and fix that. When you get into doing lengthy lab work where you're taking measurements over several days, when you start dropping ending zeros, though, it can be a real headache. So if you just get in the habit from the very beginning of always keeping up with significant figures, it may take you 10 extra seconds when you're in the moment, but it will pay off having to go back and search through and figure out where you drop zeros in the end. We're given 60 miles per hour. So the way we write that is you can travel, or you are traveling, 60 miles over or per 1 hour. Right? That's what that means? And we're asked to convert to to meters per second. So we're going to have to convert miles into meters and hours into seconds. We're going to have to do both. And there are different ways you can do this. So some students like to work it all out in one t-table. You're still going to use the premise that opposite units cancel out. That's still the same thing. Some students like to work out the 60 miles and convert it to meters in one t-table. And then in a separate t-table, convert 1 hour into seconds. And then what would you do with your meters and your seconds? Divide them. Do you guys have a preference? What if we do this one in 2 separate t-tables, and then the next one we'll do in 1 t-table, so you'll be able to see both methods. I think the doing it in separate t-tables, especially from the beginning, is helpful because a lot of kids take for granted that when we say blah, blah, blah miles per hour, we mean per 1 hour. And so they take for granted the fact that we do know how many hours. So we're going to go 60 miles into meters in one t-table, and 1 hour into seconds in another. Okay, so I'm going to start working on miles. So I'm going to go, and you could have worked this differently in different conversion factors. I'm going to go from miles to feet. Yeah. 1 mile is 5,280 feet. And then I'm going to go feet to inches. This may not be how you did it. I'm just going with conversion factors that I'm pretty sure I have memorized. 1 foot is 12 inches. And then I'm going to go inches to centimeters. I need to look at that one. 1 inch is 2.54 centimeters. And then I'm going to go centimeters to meters, which is a metric conversion, right? But I'm going to do it in my t-table just because I have it here, and it helps me organize my thoughts. So if I'm looking at centimeters and meters, how far apart are they? How far apart are the prefixes? 100, right? They're 2 steps apart, so 100. So is it 100 meters is 1 centimeter, or 100 centimeters is 1 meter? 100 centimeters, because it's smaller, is equal to 1 meter. Right? And so I'm going to get my answer there. Did everyone work it out exactly like I did? No. Is that okay? Yes. So on the top, I got 96,600 meters. You guys who worked it out a different way, did you get close to that? Yes. Yes. Yep. And then I'm going to convert hours into seconds. So 1 hour, I'm going to convert 1 hour into the number of seconds. So 1 hour is 60 minutes. And then 1 minute is 60 seconds. Did we all work that one the same? And you should get 3,600 seconds. Let's talk significant figures here. So we pulled out this 1 hour. We're just going to use the 60.0 for significant figures. So don't let this 1 hour affect your significant figures. Unless we knew how accurately they measured hours, we can just assume that that was taken into account when they found the 60.0 miles per hour, okay? Okay, so then what are we going to do with those two numbers? Divide. So 9660 meters divided by 3600 seconds. What is it? 26.8. Do we agree? So that's, let me make this smaller, equal to 26.8 meters per second. So another way to say that is the speed of 60 miles per hour is the same as 26.8 meters per 1 second.